Hello, in this video, we're going to be looking at the second part of lesson 8.2 on trigonometric ratios. If you haven't already completed the 8.2 day one notes, where we defined sine, cosine, and tangent and practice writing the ratios, you should go back and do that lesson or watch that video first. Today's video, day 2, is going to build off of that, and the essential question that we'll focus on today is, how do you use right triangle trigonometry to find missing side lengths of a right triangle? Before we jump into the new example, let's just do a quick review of what we talked about in day 1 of this lesson. We began by talking about how to label the parts of a right triangle. This is going to be really important because it's going to help us figure out which trig ratio to use. So the 3 parts are listed there. We have the hypotenuse, opposite, and adjacent. I always do the hypotenuse first because that's the one that never changes. It's always across from the 90-degree angle. Then do the opposite second. The opposite is across from the acute angle. So here the acute angle is A. Opposite is the leg across from that, the leg not touching it. And then last, you have your adjacent leg. And if you save that for last, it's just going to be the only one that's left. These 3 parts can be used to write then 3 different trigonometric ratios. A trigonometric ratio is just a ratio of 2 sides in a right triangle. The 3 ratios are sine, cosine, and tangent. Sine is defined as the ratio of the opposite leg over the hypotenuse. Cosine is the ratio of the adjacent leg over the hypotenuse. And tangent is the ratio of the opposite leg over the adjacent leg. The way to remember these is with the acronym SOHCAHTOA. S for sine, so we have O over H. Cosine, A over H, and tangent, O over A. So we're going to continue to use that as we move on to example 3, where we can now use these parts and the 3 ratios to help us find a missing side in a right triangle. In order to use trig functions to find side lengths, the first thing that you should do is label the sides of the right triangle in relationship to the acute angle that you're trying to find. The 3 sides are going to be hypotenuse, opposite, and adjacent in that order. Then you're going to use the 2 marked sides and determine which trig ratio to use. Ignore the side that's blank. Then you'll set up a trig ratio equation and then solve for the missing side using proportions. And we'll review that as we get to it, but in a proportion, the cross products are going to be equal to each other. Another important thing to note is you need to make sure that your calculator is in degree mode. And I'm going to show you how to do that here in a second. But now I would recommend that you write this down so you don't forget. I'm going to highlight this because it's super important. All of the problems that we solve in this class are going to have the angles measured in degrees. So we have to make sure that our calculator is in degree mode so that it calculates the ratios correctly. We'll jump to the calculator soon, but first, why don't we start with the first 3 steps where we just set things up and label our sides. So I'm going to start by noticing that the angle that I'm given here is angle Q, and that's the 34 degrees. So this is where we have to orient our acute angle right there at Q. And from angle Q, well, we have our hypotenuse, which is across from our 90. So the hypotenuse is this side. And then opposite the 34-degree angle is 11. And adjacent is the only side that's left. Now, in this problem, we want to find side QR. Instead of calling it side QR, just to make it easier when I write my ratios, I'm going to label that as X. That's the one that I'm going to try to find. Now, noticing in the picture, we're trying to find X, so we need the adjacent, and we have 11, we have opposite. We can ignore the hypotenuse because we don't know the length of the hypotenuse and we're not trying to find it. So we need to find, well, which of our trig ratios, so, Ka, or TOA, uses O and A. Well, if you look, the one that uses O and A is tangent. This is the TOA of SOHCAHTOA. So we are going to use the tangent ratio. And now I'll set this up. It's the tangent of the angle. And the angle, we can actually put the degree measure. So tangent of 34 degrees. And you'll see on the calculator that the degrees always go in a parenthesis. So I'm going to write it that way here as well. So tan 34 equals opposite over adjacent. So the 11 over the x. So that just completed steps 1 through 3. We labeled our sides, we determined which ratio to use, and then we set up a trig equation. Now we're going to go ahead and solve this with cross products. So to do that, you're going to make the left side into a fraction by placing it over a 1. Tan 34 is the same as tan 34 divided by 1. And then our cross products are going to be equal. So for a cross product, you just take like the x multiplied with the tangent of 34. And that's going to be equal to 1 times 11. So our cross products are equal. And because multiplying by 1 doesn't change anything, I really just have x times the tangent of 34 degrees equals 11. Now we want to find x, so we need to, get the x by itself. And right now it's being multiplied with tan 34. So to undo a multiply, we do the opposite of multiplying, which is dividing. So I'm going to take each side and divide by the tangent of 34 degrees. And that cancels it out on this side, makes a 1, so I just have x. And then now I need to go to my calculator and figure out what 11 divided by tan 34 is. And the fraction bar right here is just going to be the divide key on your calculator. So you're going to type 11, divide button, and then tan 34. And I'll show you how to do this on the online calculator. If you do not own a scientific or graphing calculator, you should use the online calculator that's posted on Schoology. Go into the resource folder on your course Schoology page, and one of the resources listed is the online calculator's scientific or graphing. To make this work the best, you should open that in a new tab by clicking this little box with the arrow. Then I'll click the link. And you can either choose the grade 6 and 7 MCA scientific calculators or the grades 8 and 11 mathematics MCA graphing calculators. I'll do this first problem with the scientific calculator. The graphing calculator works almost the same. I'll show you that in the next problem. Let's start with scientific. You need to click this blue start box twice, and then you're going to click the TI-30 scientific calculator. And the button right next to the second button at the top says mode. Our calculator needs to be in degree mode, and it defaults to RAD, which is short for radian. We're not going to use radians in this class. That's for higher level mathematics. All of our angles will be measured in degrees. So I'm going to move my cursor over degree, hit enter, and now degree should be highlighted. Then I'm going to switch it. You can either be math print or classic. It doesn't matter. I guess I'm going to switch to classic mode. And then I'm going to go second, quit. And now let's type in what we need to find our problem. So I needed 11 divided by, and then the tangent button is right here, TAN, and then it's 34 degrees. Close that parenthesis, hit enter, and there's our value. Now we just need to round that to the nearest hundredth, which is 2 decimal places. So 16.308. The 8 in the third place makes it round up. So 16.30 moves up to 16.31. And now we'll write our answer here. Again, on the calculator screen, we see 16.308. When we're rounding to 2 decimals, we look at the third spot. The 8 goes up. So it's 16.31. Also, remember that we added the x in the problem. It actually asked us to, I think, find a side. Let me get this out of the way. It actually asked us to find side QR. So when I write my final answer here, I'm going to go back to QR like this. So QR is equal to 16.31. Let's try another example. Now that we kind of know what we're doing, this next one will go a little quicker. I'm going to start by labeling my sides in relationship to the angle that's given. We have a 57-degree angle, angle E. The hypotenuse is 20. Opposite angle E would be side DF. Whoops, that's opposite. And then adjacent is the only one that's left. Now we want to find side EF, which is the adjacent side. I'm going to just shorten that to side X, and then we'll put the letters back in later. Focus on the two sides now, the one we want to find and the one we know. You can ignore the opposite because we don't need that one. So if you go back to your SOHCAHTOA ratio, look at which one uses both H and A in the same ratio. And the one with H and A is the CA of SOHCAHTOA. So that means we need a cosine ratio. So now I'm going to set that up here on my paper. So I have the cosine of the angle, which is 57 degrees. Close the parenthesis, and then it's going to equal A over H. So the adjacent is the X. The hypotenuse is 20. And now we have our trig equation set up, and we are ready to solve it with cross products. Place the cosine ratio over a 1, and then we have 20 times the cosine of 57 degrees. Close the parenthesis, and that's equal to 1 times x, and when you times by 1, it's going to stay the same. So in this problem, x is already by itself. So we don't have to divide by anything. We just need to type into our calculator 20 times the cosine of 57 degrees. Let's go ahead and do that. This time I'm going to use the graphing calculator. I'm still using the online calculator on the Schoology page in the resources. This time I'll choose the grade 8 and 11. Click the start button twice, just like we did in the last problem, and then I'm going to pick the TI-84 graphing calculator right here. And we do need to make sure that we're in degree mode, so it's kind of in the same spot as the scientific. Mode is right here. There's more choices, though. We need to move to the fourth line there where it says radian or degree, and move it over to degree. Click enter, and then we can leave the menu here, second quit, and now we're ready to type in what we needed to calculate, which was 20 times the cosine of 57 degrees. So 20 times cosine 57, close your parenthesis, hit enter, and there is our value, 10.892. So that is what we got from our calculator. Let's round it to 2 decimal places. So the 2 here makes it round down, which means it stays the same. So we'll just go 10.89. And then let's go back to, it was asking for side EF. We just replaced it with an F, with an X to make it easier in our calculations. But for my final answer, I'm going to go back to EF equals 10.89. All right, let's try another one. So on this one, LN is the missing side. So I'm going to, again, place an X on the side that I want to find. Side LN is this one right here. And then let's go ahead and label our sides. The hypotenuse is the X. The opposite, the 47-degree angle, is this 14. And the adjacent is that side there that's unmarked. Because I have the opposite side of 14 and I want to find the hypotenuse, if you go to your SOHCAHTOA phrase, the only one that uses both O and H is SO. So therefore, we need to use a sine ratio. So now we'll go sine of, and then we use the angle measure. So sine 47 equals opposite, so 14 over hypotenuse x. And now we can go ahead and solve with our cross products. So I'm going to do my x times the sine of 47 degrees equals, and then 1 times 14 is just 14. Here, x is not by itself, so we do need to divide the sine of 47 to get x alone. When you do that, it will cancel out on this side, and x is just the value that we get when we do 14 divided by sine 47. You can type that in your calculator. Again, make sure that you are in degree mode. Once you've placed it in degree mode once, you shouldn't have to do that again. But if you ever close the calculator and then reopen it again, if you're using the online one, it will default back to radian. But if you can just keep it open in a tab on your computer, if you put it into degree mode on the last problem, it should still be there on the next one. Here, I'm going to just go back to my graphing calculator. The buttons work the same exact way on the scientific, so use whichever one you have or the one that you're most comfortable with using online. And we needed to type in 14 divided by, and then it's sine 47 degrees. Be sure you close your parenthesis, hit enter, and there's our answer. We'll round it to the nearest hundredth, 2 decimal places. So that 2 in the third spot makes it round down, so we'll keep it as 19.14. And then now for my final answer, I'm just going to go back to calling the side ln, the one we were asked to find, and ln is 19.14. All right, let's try our last example of this problem set here. In letter D, we want to find side AC. So I'm going to label side AC with an X right here. And then we'll label our sides in relationship to that 32-degree angle. So I guess I should maybe do my hypotenuse first. So the hypotenuse is here. Opposite is across from the 32, so that's the 31. And X is adjacent. Now we want to ignore that blank side, so I want to focus in on the one I'm trying to find, adjacent, and the one I know, opposite. And if you look at your SOHCAHTOA ratio, the one that uses O and A is tangent. So we can set up a tangent ratio where we have the tangent of 32 degrees equals O, which is 71, over adjacent, which is X. And now let's go ahead and solve with a cross product. X times the tangent of 32 degrees is equal to 1 times 71, which is 71. I need to get my X by itself, so I have to undo that multiply by tan 32. And when we do that now, we can just go to our calculators here and type in 71 divide by tan 32. And when you do that, your calculator is going to give you 113.623. For rounding purposes, if the 3 there is going to round down, so we'll say that side AC is 113.62. Please pause the video now and try that try now on your own. When you hit play, I will have the answer posted. Please pause your video. Okay, here is your solution. We are trying to find ZY, which is opposite the 70. We have the hypotenuse 16. So since we have an O and an H, we need to use our sine ratio. So the SO of SOHCAHTOA. So I set up a sine 70 equals X over 16. Doing our cross products, 16 times the sine of 70 is equal to X. X is already by itself, so we can just go right to our calculator and type 16 times sine 70, and we will get 15.04. All right, so that concludes this example. We have one final example, example 4, and it's going to kind of build off of this problem, just a little bit different. Okay, so in our last example, we need to kind of know what an altitude of a triangle is. So that's a new vocab word. For us, the altitude of a triangle is a perpendicular segment from a vertex to a line connecting the opposite side. Okay, so from a vertex, and the vertex we're going to look at is the right angle. So right here, this is an altitude. And it says use trig or the Pythagorean theorem to find the given part of a triangle round to the nearest hundredth. In example A, we have the altitude of a hypotenuse of a right triangle has a length of 10. Notice that's already marked. And TS is equal to 14. So here's TS, 14. And we want to find PT. So I'm going to put an X. Notice that orange triangle that I just outlined is a right triangle. And we don't have any of the angles, so we can't use trig. But we do have two sides, so we can use the Pythagorean theorem. So if we have two sides, we're going to use the Pythagorean theorem. So here, A, B, C, remember C is the hypotenuse, so C has to be the 14. A and B are the other two sides. So using our formula right here, A squared plus B squared equals C squared, we would have X squared plus 10 squared equals 14 squared. So this Pythagorean theorem is just a review from the last unit, from Unit 5. Squaring 10, we get 100. Square 14, that's 196. We need to get x squared alone, and then we'll go to our calculator. So I'm subtracting 100 from each side to get x squared equals 96. Remember that to undo the squared, we have to use a square root to undo the squared, to undo that 2 exponent. So you're going to take your calculator and take the square root of 96. And when you type in the square root of 96 on your calculator, it ends up giving us 9.797. The 7 there makes it round up, so we'll go 9 after 7, 9 comes 80. So we will have, for finding PT, we would have PT equals 9.80. All right, one final problem here. In this next one, we're given that angle K is 24 degrees and JK is 13. So here's JK, 13, and we want to find KL. So KL is all the way across here. So I'm looking at the big triangle on the outside. That's what I want to find. And I don't have JL, so I'm not able to use Pythagorean theorem here because I only know one side, 13, and I want to find the other x. But since we have one angle and one side, we're able to find another side using trig. So think SOHCAHTOA. Looking at that outermost triangle here, across from the 90, we have the x, so we're missing the hypotenuse. Opposite the 24 degrees is this JL side, and adjacent is the 13. Well, we have adjacent 13. We want to find the hypotenuse, so we're going to need to use the CA of SOHCAHTOA and set up a cosine ratio. So cosine of 24 degrees is equal to A over H, so that's 13 over X. Solve it with your cross products now. X times the cosine of 24 is equal to 13. I do need to divide both sides by cosine 24 to get my x alone. And then we'll just grab our calculator and type 13 divided by the cosine of 24. And when you do that, the calculator is going to give you 14.230. For rounding purposes, 0 rounds down, so that missing side, KL, is just 14.23. So I know this video is getting kind of long, so I'm going to have you do the try now all by yourself. And if you pause your video now, when you hit play again, I will have the solution to the try now. All right, here is your solution. You can look through that and pause the video if needed. Thanks for watching, and good luck as you practice some trig on your own. Bye.